What happens if I have something that isn't a squared? In other words, if I had a radical that was like this, the cube root of x minus 3 equals 2. Okay, is it by itself?
Yes.
Yep, the radical is by itself, which means the index is 3, so I need to get rid of the radical, which means I need to cube both sides. Still be x minus 3 equals, now I have 2 cubed, which means that I would have 2 times 2 times 2, which would be an 8. Bring the 3 over, gives me an 11. Okay, take the original problem, put it in. 11 minus 3 equals 2. So it would be the cube root of 8 equals 2. What's the cube root of 8? 2. So does 2 equal 2?
Wait, why is it 2? Yeah, why is it 2?
What's the cube root of 8? What times itself? 3 times will give you 8. 2 times 2 is 4, times 2 is 8. So 2 is the cube root of 8. So I got 2 equal to 2, right? So x equals 11 would be my correct solution.
How big will the index get on the homework?
What?
How big is our index we get on our homework?
Oh, I see, maybe up to a 4.
Is there going to be any fractions?
Oh yeah.
Can you teach us how to do a fraction?
You mean a fraction as an index? Or huh? They probably will not have a fraction as an index. Okay? So that would not be good. We're going to do, first of all, though, one that has now radicals on both sides, doesn't it? Okay? Radicals on both sides presents a special problem. Which one do I isolate? Good question. I'm going to have to do one of them, and then if I have a radical left over, I'm going to have to do it again. Okay? Whenever I'm isolating a radical, I would probably isolate the more complex one first. In this case, this is more complex than this one. Wouldn't you agree? Since I have an index of 2, what do I need to do to both sides? So that means I need to square this side and also square that side. Well, this one's easy to square. What do I end up with? X minus 12 equals. What does this actually mean if I have a binomial that's squared?
2 squared and negative root of x.
It actually means that I have to do this. Right? Which means, what method am I going to use? FOIL method. So 2 times 2 is 4. 2 times the negative of the square root of x is a negative 2, the square root of x. A negative the square root of x times 2 is a negative 2, the square root of x. What's a negative times a negative? The square root of x squared. Because x times x is x squared. So I need to simplify. I have x minus 12 equals. These two can add together, so I have 4 minus 4, the square root of x. Remember yesterday when we talked about the square root of 3 plus the square root of 3? You added the coefficient or the number in front, and this radical stayed the same, right? Okay? Plus x, because isn't the square root of x squared x? Okay? I got all kinds of stuff now, don't I? Well, I still have a radical, don't I? What do I need to do with that radical? I got to isolate it by itself, don't I? Do you want to leave it on the right-hand side, or do you want it on the left-hand side? Okay, so if I want the radical on the left-hand side, that means I'm going to have to add 4 the square root of x to both sides. If I bring the radical over, don't I take the x and the minus 12 over to the right-hand side? So what's this become? A negative x? And I have to add it to x. That's 0. This negative 12 becomes positive 12. 12 plus 4 is 16. Okay? If possible, I would take this coefficient before I started squaring into this whole number over here. Will 4 go into both 4 and 16? So I actually end up with the square root of x equaling 4. Because I divided both sides by 4. Now what do I do to both sides? Because I isolated a radical. Square them. So the square root of x squared becomes x equals 16. That's 4 times 4 is 16. Right? So I have to take this 16 and put it back into the original problem, which looked like this. So if I put it back in, here's the 16, here's the 16, right? So I'd have 4, square root of 4 equals 2 minus 4. This becomes 2 equals negative 2. Does this side equal that side?
No.
So do I have a solution?
No.
So I have no solution. Okay?
Let's do another one.
Another one like that? Okay. So we would have x plus 15 equals 5. Now let me change it a little bit here. Minus square root of x equals 5. Two radicals again. I need to isolate one of those radicals, correct? And I said, most generally, the easiest way to do that is to isolate the more complex one, right? So I want to try and get this one by itself on one side, because this one looks more complex than just this, doesn't it? So if I do that, I'd have x plus 15 equals 5 plus the square root of x. Square both sides. I have a binomial again over here, don't I? Two terms. So I'm going to end up using the FOIL method. But what is x plus 15, the square root of squared? Equals. I would write this out so you remember to multiply everything together. So on the left hand side I have x plus 15 equals 25 plus okay, square root of x squared. Are we okay so far? So now I have x plus 15 equals 25 plus 10 the square root of x plus x. Which side do you want to isolate the next radical? So that means move it over to here, so I'd have a negative 10 the square root of x equals, I'm going to bring this x from the left hand side to the right hand side, so that means subtract x. They cancel out. So they're gone, right? What do I do with a positive 15? So it'd be 10. Okay, I can, but will this number here go into this one? I'd try that first, okay? Just to help simplify it. So I divide both sides by the negative 10, which is going to give you a negative 1. Wouldn't you rather square negative 1 than square 10? Okay. Now I do what you say by squaring both sides. X equals 1. So taking my original problem, putting back in the x values, 1 plus 15 is 16, minus the square root of 1 equals 5. So you say this is 4, isn't it? Minus 1 equals 5. So 3 equals 5. No solution. Okay? Sure. Just hang on here a second.